Okay, so I'm talking today on on-demand scientific services at ALCF in particular. This sort of started as a fun little project of somebody came to me with AlphaFold, which is a pretty data and compute intensive machine learning algorithm. And they asked me, how do we make this available to a community of users at ALCF using funcX? And then this quickly spiraled into a wider conversation with the APS and ALCF about how do we do this properly? How do we actually stand this up as an ALCF capability with funcX as an interface? And what are sort of the roadblocks and things we need to improve on there? So first things first, just the general motivation about leadership computing facilities, extreme scale, specialized hardware, all of that, enormous data sets. This one I think is becoming increasingly important with just how large these simulation data sets get. You can't act on them unless you have access to these machines, is essentially the takeaway. Even AlphaFold's an example here. I don't understand why, I don't understand AlphaFold, but it's got 2.5 terabytes of reference data that you need to be able to use the model. And then on the sort of flip side of all of this is how restrictive these machines are to use. So if you're familiar with them, it's great. Yeah, it's not too bad to understand how these queues work, understanding that you've got to acquire in 128 node batches and all of that sort of thing. The authentication and authorization requirements are fairly strict. At ALCF, you have to have an ALCF account. You have to go through the process of getting a 593 if you're a foreigner and all of that sort of thing. And none of this is a huge roadblock if you're familiar with it, but it seems like if you're not familiar, if you're unfamiliar with these sort of module loads and all of that sort of thing, it's quite a stumbling block to actually get up and running. And it seems like funcX can simplify access to this data and this compute if we can get it in front of that and get it signed off by the facility as a approved mechanism to getting jobs into the facility. So just quickly on AlphaFold, because I really don't understand how it works, but it's a cutting edge machine learning technique to predict protein structures. And it's got multiple applications and things like high throughput screening pipelines and development of therapeutics. The light sources use it. I work quite a lot with a couple of crystallography groups at the lab at the photon source, and they're really interested in it. And yeah, basically you give it one of these faster files, and at the end of about an hour and a half of processing on a GPU, it gives you back a large directory, which I assume has one of those pictures on it. I don't know, somebody else downloads it and I'll just start nodding. So there we go. Yeah, okay, so what have we actually done? We deployed funcX at ALCF, and we made it so anybody that has access to this funcX endpoint is able to run AlphaFold on demand, and it will provision nodes, it will do all of that sort of stuff, and then get the result back to you. So this is really, we've started funcX on these machines, and we've, I don't want to say opened up, because I know there's some ALCF people in the room, but we've made it vaguely available to a very select group of users. So the long and short of how this is actually run is the user provides a FASTA file, which is one of these sequences or a collection of them. That FASTA file is uploaded to ALCF. We store it in Eagle storage system, the sort of Globus endpoint there. It's got 100 petabytes of storage, so we've got plenty of space to do this. funcX then provisions GPU resources on Polaris, and then the task run for about an hour and a half, and results have been shared back via that Eagle collection. So we make the results HTTPS downloadable for users. And then, yeah, we actually, we wrap this all in a flow as well to simplify things, because nobody wants to sit there polling their task for an hour and a half. So it will send you an email about when it's done and give you a nice link to where to go and collect your data. So under the hood, what does this actually look like? So this is where we sort of show that it's a bit more prototypey than perhaps I just explained it as. But basically, I've started a funcX endpoint in my own account on Polaris Login 1. And this is shared with a private Globus group. So this is extremely locked down at the moment. There's only 4 people in this Globus group, and anybody in that group has to have an ALCF account. We are not sharing generally. We're not doing anything like that. So it's, we'd get in a lot of trouble if we did that. So we're not doing that. It's a Singularity enabled endpoint. So I'm not sure how many of you guys have actually seen Singularity enabled funcX before, but this is, I pasted a config here to sort of show that it's using a container type of Singularity. We've got container options there of using GPUs for -NB. We set a home directory just to my home directory, and then the rest of it's cut off, but we're mounting the project space to get that reference data and Eagle to store those results. And then, yeah, you can see it's acquiring GPU nodes with that select options there. So this is a proper config for Polaris. If you copy paste this, it'll work. And yeah, from there, it uses a preemptible queue. This is purely because it's nice and fast to get nodes and it's very flexible. At least you acquire one node at a time, at least you acquire 4 nodes at a time, up to 72 hours. So we can happily put in a 6-hour wall time there. And then, yeah, as I said, it all runs in my account. So this is basically we're using funcX sharing to allow other people to multiplex into my account so the jobs actually execute as my user under the hood. And this is important because ALCF needs somebody to blame if something goes wrong. And I'm on the other side of the world, so Mike can't come and get me in person unless he comes on holiday. From there, we've created a custom singularity container. So basically, we took Harry used AlphaFold singularity container that he's provided on GitHub, and then we've added funcX into it. So this is just so our workers can actually start inside that container, and then we can execute functions inside the container, and they can use the AlphaFold tools that are encapsulated in there. We've predefined and registered a funcX function that takes the necessary arguments. It takes what model, what data, what reference data you want to use, how many GPUs you want to use as input parameters, and then we've configured that to use that AlphaFold container. So this is just statically coded. You'll see I've got a little CLI. This is just hard coded in there to actually use that. And then we've also deployed a Globus flow that sort of wraps around all of this and does the emailing of results at the end of the day. So in terms of using it, anyone can use it if you're in that Globus group. So we've got a little Python CLI there that you just pointed at a FASTA file, and then an hour and a half later, you get a nice email saying, here's your result, which is kind of cool. You can also go and use this. We've got a notebook that I share around with anybody that's interested in using this thing that just actually runs the flow yourself. Yeah, basically I've registered the flow, so that flow ID is basically static. And then I've just made that runnable by anybody in that Globus group. So anybody in that group is able to execute this flow, and then it will pass through all of the necessary credentials. And yeah, you get this nice little email back. So probably the most interesting part of this was the discussion that then came with ALCF of how do we actually want to do this? We can't have every user using AlphaFold in the world running as me on ALCF. I'll quickly become a great ALCF user, but that's all right. So the path forward here is actually to have service accounts. So I've been in a number of chats with Mike and Bill at ALCF about how we want to operate these service accounts, how we want to spawn them, who owns them. And this is really important because this is no longer a user running every job. It's actually this service account running every job. So that service account would be tied to AlphaFold. So every job would be AlphaFold running a workload. This is very similar to how we're going to do the APS work of a beamline having a service account. So every job comes in as a beamline and executes that way. The way we can then actually run the endpoint as sort of an entity rather than a user is we've added support for Globus app credentials into funcX. So you can mint a new Globus app, take that the secret and ID, and then actually run an endpoint as this credential rather than a user. So it's no longer owned by a user, it's owned by that credential. ALCF has all the power to take away that secret and invalidate that credential, and then suddenly your endpoint doesn't work anymore. We need project allocations, so we need to be able to monitor and manage resource utilization. Currently, I run everything as APS data analysis because that's a project that I mostly use. So yeah, all AlphaFold jobs are going through that at the moment, but that's not ideal. We'd rather have more fine-grained analysis on what AlphaFold jobs are being run. We can prioritize them, we can limit them, etc. There's quite a lot of interest in how we actually manage the functions. So currently, I've just registered a function. Nobody knows what it does except me. It's just in a Jupyter notebook somewhere where I'm developing that. So Mike and co want a way to actually vet these functions, make sure that they are doing what they say, make sure they're not doing anything stupid. And then they need sort of these management capabilities or administration capabilities to actually add and remove functions from an endpoint. So this is sort of coming back to that idea of whitelisting functions on an endpoint so we can restrict which ones are allowed to run there. So just because a user is being granted access to this endpoint, they can't start running their own Bitcoin miners or whatever. So yeah, we need to be able to do that. Managing user access becomes quite interesting. So I think the Globus group model is quite nice here. It gives us a lot of auditing capabilities around it if we sort of hand it off to funcX to manage who's doing what on this endpoint. And yeah, that really comes back to our reporting as well. So we need better capabilities in funcX to report out these user statistics, show which users are running what at any given time, because that's really important to ALCF to be able to point that blame to this user was doing something malicious. An interesting one that I know Yadu talked about just before was being able to stop bad tasks. So to me, this has never really been a problem. It's my endpoint. If something's going haywire, I kill the endpoint. They obviously think about this in a bit broader of a scope where they don't just want to kill the endpoint because other people are doing things. So yeah, that's kind of a sort of push towards us supporting task cancellation and that sort of thing. And then this other one is really around persisting endpoints. So on ALCF, I've set up some cron jobs to check my endpoints there. I know Chris Scott gave that talk yesterday where he's written a nice shell script that SSHs between login nodes to check where your endpoints are running and then kills them if they're on bad ones. So that's something that we need to look more at. And Bill and Co are actually starting these service nodes at ALCF on Polaris. So it'll be an out of rotation login node that we sort of had dedicated access to run these funcX endpoints on. And then even look toward containerization as a way to manage these things going there. Yeah. So final steps, basically ALCF is currently working on a process to vet functions so they can hand this off to other people. And I see it's taken a while here. That it should be saying 1 minute. This is my last slide. So yeah, lots of things to do. Yeah, work through service accounts, persist endpoints. From our side, funcX, we need to improve auditing capabilities to the public. I know exactly what's running at any given time. You, the user, probably don't. So that's something that we can work on. And then, yeah, just start folding it into more use cases. Basically, yeah. Cool. Thank you.
All right. Dan, that's a question? Yeah, I guess when you're talking about this reminds me a lot of science gateways. Mm-hmm. And so I guess I'm wondering, does Argonne support any science gateways now? And if not, like how is this different than what all the NSF supercomputers are doing?
Yeah, it's a good question. So my understanding is there is not an official route for supporting a science gateway at ALCF. They've talked a lot about standing up Bastion nodes and service nodes, and I've requested them for a number of years. But as far as I know, that's not a capability that's provided.
Also, before anybody gets any ideas, can you please talk about how groups and sharing is locked down?
Oh yes, it's very locked down. So you yourself as a user of funcX cannot share an endpoint. You can't make it accessible to other people. You've got to go through the funcX team to actually get that toggled on in a database to associate an endpoint with a Globus group. And that's purely because we just can't facilitate users sharing endpoints willy-nilly on these big machines. So it's just, yeah, it's not something that we can allow, so we don't.
Mm-hmm. So I know it's early days, but have you given any thought about how this might intersect with Garden?
Well, I think it's a very similar model. I mean, if we can push this through with ALCF, get the vetting process there, and then we can fold that into model vetting, I think it's the exact same thing. And it folds perfectly into the APS work as well, with providing APS analysis functions as a service. I think it's all, yeah, it can really dovetail out.
Be good to start thinking about that as a use case early on to drive things.
So if I wanted to use something like this for, let's say, running 1,000 proteins in 1,000 people, would it make sense to use this approach, or maybe something else?
Yeah, it's so I think it probably would. I mean, if you're on the machine and you're comfortable with how it's working and you've got one workload that you know what you're trying to do, you can probably just put in one Slim job, one PBS job to run the entire thing. If you're more familiar with a notebook from your laptop and you just want to scale off 1,000 of them, just throw it in a loop and it'll mostly work, yeah.
So it would parallelize?
Yeah, it scales up dynamically. So every new task it gets, it provisions a new node, then puts that worker in. Once that work finishes, it reuses a node, etc.
All right, we are a little bit over time.
Sorry, I blame Yadu, not me.